Hello, good afternoon, everybody. I'm Sreeram from EigenLayer. I started the EigenLayer project like 3.5 years back and used to be an academic professor at the University of Washington, Seattle, run the UW Blockchain Research Lab, and been working on EigenLayer over the last few years. Okay, so in this talk, first I'll start with what some of you may know or think about EigenLayer. EigenLayer as restaking, DeFi, LRT. Maybe a few people heard of EigenDA. Leverage, overloading consensus, or we write a lot of academic white papers. So this is what most people know us for. So what I want to do is explain what we are doing, what the EigenLayer project is, and how it relates broadly to the overall crypto project that we're all here together building. So to frame this whole setting, I want to start with why build crypto apps? And because when you start with the clear motivating problem, it's easy to then see like what set of technologies are needed. Okay, there are a few theses for why build crypto apps. The first one, you use crypto for payments. It's like a Stripe API. You just, whatever thing you're doing needs some like global payments, just swap it out, use crypto underneath it. It's probably useful, but it's not that useful. Stripe's pretty good. The second one, use crypto to decentralize your apps. You have an app, you have Uber, you have Twitter, you have all these things. Or make them decentralized. That's a thesis for why build crypto apps. But no user cares about decentralization. Okay, so it's not clear there is any product market fit for this. We have a thesis for why build crypto apps. We call this apps with commitments. Okay, what is this? Sounds like friends with benefits. Okay, what is apps with commitments? Okay, so let's look at the OG of them all, Bitcoin, right? What is Bitcoin's PMF? Bitcoin's PMF is, it makes two commitments. If you look at any normie podcast on Bitcoin, you hear only these two things. You own your coin. There is only 21 million coins. That's it. These are the two commitments that Bitcoin makes. All of the technology of trust underpins the ability to make these commitments. Okay, next, you think of what other crypto products have product market fit. So something like Uniswap, right? So if you think of something like Uniswap, see like what is the PMF or what is the commitment that Uniswap makes? You get the fair market price of your asset. Just put your money into a Uniswap pool, you get the fair market price. How do you get the fair market price? You get the fair market price because underlying your application is a bunch of services that make those commitments. For example, you need a ledger on which all the order book lies. So that's an ordered ledger. You need censorship resistant for that ordered ledger, and Ethereum provides you that. So you go next, something like Aave. What is Aave's product market fit? Aave's product market fit is a commitment that a borrower is solvent. Okay, think of a lending market. You're going and lending your assets into a market. And what is your biggest concern? Your biggest concern is that the borrower is going to run away with your assets. That's your biggest concern. If I can give you a commitment as an application that the borrower is solvent, then you have everybody will lend. How do you get there? You get there by actually getting a bunch of underlying services. You need a service of an ordered ledger. You need censorship resistance. You need an oracle. And you put these three together and you get Aave. So each app is trying to make a commitment. And to make these commitments, you need to bundle, package, use, underlie a set of services that actually help you make these commitments. For example, Aave may use an oracle like Chainlink. Okay, Polymarket, you want to get the free market odds of your event. So the app is making a commitment to you that what odds you are getting are the real odds of the event. And the way you get it is you have a bunch of underlying services which offer an order ledger, censorship resistance, Oracle. You have an off-chain order book. All these things, you take these underlying services, bundle them together to make apps that make commitments. Okay, so this is the first part of our thesis. If you want to build a crypto app, and the core part of building a crypto app is it's making commitments, you want services that actually make these commitments. So now we're ready to explain what is EigenLayer in this context. We call it the Verifiable Commitment Cloud. So when an application, so at the top you see verifiable apps. I just said apps make verifiable commitments. That's the whole point of trying to build these apps. But how do you build these apps? Today, building an app in crypto is like building an app in Web 2 back in 1995. If you want to build an app in a web application in 1995, you would have to build your own server, your own database, your own payments, your own authorization. Today, you wouldn't do that. If you're building a web application, you go to the cloud, you go and use MongoDB, you go use OAuth, use Stripe, all these software as a service, and then you bundle them together to build your app. What we want to do is to bring the same thesis of application building to crypto. So you have apps, verifiable apps. The way you build verifiable apps is by concatenating, utilizing verifiable services. But how do you get verifiable services? They themselves are built or utilize certain primitives. And okay, so primitives just like service, but at an even deeper level. And so how do you get these services and primitives secured? The way you secure them is they're run by a group of nodes which are staked, and the stakers are themselves making commitments that they're running that service correctly. So you see, start from the idea that apps are making verifiable commitments, and then you say, no, the way the apps make verifiable commitments is that they use services that make verifiable commitments, which may use primitives that make verifiable commitments, which themselves are able to make those commitments because stakers and operators make verifiable commitments. That's the whole picture of what EigenLayer is, and that's why we're calling it the Verifiable Commitment Cloud. So it enables anybody to build these services on top and applications to come and utilize these services to build new and interesting applications. Okay, so one thing to see here is there is a lot of discussion in this meeting today about roll-ups and composability, right? Of course, we are in Composability Day. How does EigenLayer relate to this whole roll-up era? So you can think of like what we call the 4 levels of open innovation. So take a blockchain like Bitcoin, which is an application-specific chain. Bitcoin is built for sending and storing Bitcoins. The Bitcoin blockchain is built for sending and storing Bitcoin, the asset. So you have these different layers. You have a security layer, a consensus layer, an execution layer, and an application layer, all bundled into a common framework. So that's what you get with Bitcoin. What Ethereum did is Ethereum modularized the application layer. Anybody can come and build applications on top of Ethereum. So this is the whole era of smart contracts and decentralized applications that many of us here participate in. The next step that Ethereum took is expanded the scale of innovation even more to a place where you not only can innovate at the level of applications, you can also build your own execution environments, your own virtual machine, your own custom application logic at the level of the execution environment. And you prove it back to Ethereum on a common security substrate. So this is great. This is where we are till today in the Ethereum rollup-centric roadmap. But what it doesn't let you is change the underlying consensus, the way by which the Ethereum nodes come to consensus, it doesn't let you change it. It doesn't let you borrow trust for your own consensus network. And what EigenLayer does is take this one step further. What is the step? You have a single, so if you look at where security comes from staking, right? In a proof of stake network, nodes put out stake, and then they make promises that they want to run it correctly. What EigenLayer does is to say, there is a layer of shared security, shared stake, and now like anybody can build these networks, consensus networks, on top of it, and then on top of which you can build new execution environments, new applications. So this is the deepest level of open innovation. Because now you can express pretty much any decentralized verifiable service on EigenLayer. Okay, just taking this exact like progression and running it to its endgame. So you see when you think about it in the roll-up-centric roadmap, one of the things you see is, oh, how do I build a decentralized sequencer? How do I build a decentralized bridging service? How do I build a decentralized MEV management? All these things now just become services that can be built on top of EigenLayer. So this is the transformation that we are hoping to usher in. Okay, so having said the kind of like context for what this verifiable cloud is, we can look at how the marketplace structure looks like. So the marketplace is basically, we start with stakers and operators. Stakers and operators come and they are in this network and they provide security to AVSs. What is an AVS? An AVS is a service built on EigenLayer. We call it Autonomous Verifiable Service, AVS. Autonomous because it runs on its own. Nobody can stop it. Verifiable because if you don't do something correctly in the service as a staker and operator, you're going to lose your stake. So we call these services autonomous verifiable services. So if these stakers and operators supply security, and then services can now be built on top of it. So initially, our picture of EigenLayer was just stakers, operators providing services, and providing this framework for AVSs to build. Now what we've done is take this picture and say, hey, if there are AVSs which can consume this stake and actually build useful and interesting services, that's not the end of the chain. You want these services to be used by apps, agents, and other things. And so that's the next side of this flywheel. Applications and agents come and consume these AVSs. And as you get more and more of these using the same shared security substrate, you can actually get more and more value through the system. Okay, so where are we in this market structure? It is a very complicated, multi-sided marketplace. It's a very complicated, multi-sided marketplace. We started with stakers, then we went to operators, then we went to AVSs, then we have to go to apps and agents. Okay, so where are we in this market? So we started with stakers. So this is maybe the only thing most people know about EigenLayer is staking. Right, so we have a lot of stake, tens of $13 billion in stake. And many of the top players in the ecosystem work with us. So, okay, so now you have stake. Stake is a form of economic security. Now the next step is you need to get operators. Where are we in operators? We have 1,900, nearing 2,000 operators around the world participating in the EigenLayer ecosystem. This goes from all kinds of home operators to Coinbase and Blockdaemon to Google Cloud running a first-party operator. So we have the entire spectrum from Web2 to home operators on EigenLayer. The next side of the marketplace is AVS developers, people who build and deploy autonomous verifiable services. And this is a new category. So the first thing to understand about these autonomous verifiable services is building an AVS is like building an L1. It's a very complex endeavor, at least as of today, because you're building a whole new decentralized protocol with its own consensus. So there's a lot of steps in building this and getting this right. So it's the hardest side of the marketplace to bootstrap, because when an AVS developer comes and looks for what platform to build on, it's very difficult to convince them to build on our platform, as an example, because they're taking a lot of platform risk because this whole idea of what is EigenLayer and how it is going to evolve is very new. So they're building these trains as we are laying these tracks for how EigenLayer works. Okay, so that's the AVSs, and my guess when we started EigenLayer was AVS is going to take a long time to manifest and get, but I'm really surprised at how fast it has moved. We are now at 100 plus AVSs in various stages of development, 30 plus on mainnet. So really excited about all the progress that is happening. And it's, like I mentioned, the 4 levels of open innovation. This is a new primitive for enabling anybody to come and build new decentralized services. Okay, what are these AVSs? Who's building them? Here's a category map we laid out some time back. And it just lays out all the different categories that one may be interested in, whether roll-up services, scope processes, cryptography, proofs, other kinds of things. It's an old map of what we wanted or what we were hoping will happen in the ecosystem. And we're very happy to see that there is actually interest in each one of these categories. And many categories have many, many different players. Okay, so as we think about this verifiable commitment cloud and these AVSs, that is our attention. What are we doing? Okay, I mentioned AVSs, but one thing that as we started helping people build these AVSs, we discover foundational problems in this whole architecture. And if a problem touches all AVSs, then we are in a position to help solve it. So we call these primitives. Primitives are underlying services that help pretty much all services. So what are these primitives? And we've built 2 core primitives till now. And as we start understanding what the AVS structure is, we may need to build other primitives. Okay, so what are these primitives? So the first one is the Eigen token. Okay, so what is this token? What are we doing with this? So today, if you look at it, with staking, slashing is how you make sure that the stakers and operators stay honest. And if you're saying that the stakers and operators need to remain honest, then you need to have an on-chain fraud proof, an on-chain proof of violation. But so writing on-chain proofs can either be complex or impossible. Okay, why is it complex? Writing it can be complex because, as we know, for example, in the roll-up era, writing these fraud proofs for these roll-ups has taken many years because what you're doing is virtualizing one virtual machine on top of another virtual machine. It's an extremely complex endeavor, so obviously it's going to take time. The other one is there are several faults that are simply not observable from the standpoint of Ethereum. As an example, if a network of nodes do not serve the data to their customers, so data availability is an example. If a network of nodes do not serve their data correctly to their customers, how does Ethereum know about it? Because it's not transparent on Ethereum. So there is a bunch of these faults which is not observable on-chain, on Ethereum, but it's observable off-chain. And so we think of systems which can have very complex fraud proofs, like a gaming or a database or intent or order matching, MEV engines. These can be theoretically built on-chain, but they're very difficult. So you can build any service which has an off-chain provable fault on EigenLayer or using the Eigen token. So the Eigen token is a new token. How it works, all that is too complicated to go into here. But the output property is any fault which is off-chain attributable. That we can run a node, we can observe from the outside. For all of those faults, you can slash the Eigen token. So that's the new and interesting thing. But what that extends to is there are many categories of services which simply cannot be built. Today, like data availability is one, prediction markets. How do you know Trump is the president or not on-chain? There's no observable locus to it. How do you know that an ordering service censored transactions or not? If you're running a P2P node in that, you may know it yourself, but on a blockchain, you don't know. Similarly, AI is a huge category where training, inference, benchmarking, all this stuff needs, it's very difficult to build on-chain observability, but you can easily observe violations off-chain. Okay, the second primitive that we are building is EigenDA. What is EigenDA? If you think of crypto economic security as like I stake, and then I promise that I'm going to run the service correctly. And if I don't run the service correctly, anybody can raise their hand up and initiate a fraud proof or a slashing proof. That's what we can do with EigenLayer. But if the data relative to that system is not publicly available, like how are you going to raise the fraud alert? So data availability is a core problem for all of our AVSs, which is why we built EigenDA. So a system of crypto economic security cannot function if it does not have plentiful data availability. And so that's what we built EigenDA for. And we obsessed a lot about when building EigenDA to make it horizontally scalable. There is no single point in the network which needs to download all the data. Every node only downloads a small fraction of the data, but the system inherits the full security of the network. So our throughput right now on mainnet is 15 megabytes per second. We have a lot of upcoming integrations into the system. There are also some special features like, we have reserved throughput. You can just, one of the problems that you face with DA is, for example, on Ethereum blobs, base may be using Ethereum blobs today, and then 3 weeks later, and they may be paying 20 GUI or whatever, and in 3 weeks, the price may shoot up to 200 GUI, make it impossible for users to actually use that rollup. So, in cloud, this problem was called the noisy neighbor problem. Like, you're on a certain instance and you're sharing it with some other, apps, and those apps spike in demand, and then suddenly you are out of throughput. So you don't want that. So you can actually get reserved throughput. And you can use your own token for staking for your rollup in DA. Okay, so those are the two primitives. Now I explain the whole picture of what is EigenLayer, this multiple levels of primitives, services, and apps built on top. And we have a roadmap for each one of these. What have we done, what is in progress, and what we're exploring. Okay, but I'll wrap up with talking about one major place which we are very excited about. So, I said EigenLayer is verifiable commitment cloud. If you look at what is happening today in cloud, Satya Nadella from Microsoft recently announced that Azure is investing $80 billion this year in AI. $80 billion this year in AI. And why? Because AI is the biggest demand driver for cloud, obviously. And so it's the same thing for the verifiable cloud. So if you think about the verifiable cloud, there is a very good match between what is crypto's problem and what is AI's problem. What is crypto's problem? We don't have apps. You go around ETHDenver, ask what is crypto's problem. We have an adoption problem. We don't have apps. What is AI's problems? AI's problem is it doesn't have trust. How do you trust this stuff? It's deep fakes. It is, agents go rogue. Can you give your money to an agent? Can you run a company with an agent? All this stuff has a trust problem. And I think crypto can uniquely solve AI's trust problem. And AI agents are really the new apps. AI agents are the new apps. This is kind of like a standard Silicon Valley thesis that agents are the new apps. And so bringing these two together is going to be where a lot of value is created. And we're investing a lot in this. I'm not going to talk about this. There's whole categories that are being created inside AI, AVSs. Whether it's data collection, generation, attribution, storage, model training, fine-tuning, evals, agent runtimes, crazy stuff. Each one is a hard problem. And we have teams which are starting to build each one of these as separate AVSs. Somewhat like the aspirational category map I presented for general AVSs as a whole thing for AI. I think with that, I'll conclude this talk and thank Ben and the team for the opportunity.